So last time we had a look at gain, entropy, and we actually started understanding the pardon me, the decision tree, right? So any doubts on these topics so far? Have you understand the gain, entropy? Could you be able to explain by yourself?
Yeah, I understand.
Yeah. Could you put it in your words, sir? What do you mean by gain or entropy?
I have it in my notes. Give me 1 second.
Okay, no problem.
Yeah.
Anyone else? Because see, you need to explain it before the interviewer, right? So I'll be there, but basically you need to explain it in your words so that you feel confident. The interview should know, like, you know what you're talking about, and you can generate solutions in data science. Basically, that's the predominant need of the hour, right? So
Right.
you explaining in your word is really make this much more easier, simpler, and a kind of progressive way to discuss further. Anyone else? Rajni ma'am?
Not really. I understood the concept, but I am not at a level to explain this yet.
Okay. Please do revise because interviewer might ask question, right? So we need to prepare on those as well. And in addition to that, if you could really think it through, like this is a normal common question in interview. Tell me about yourself. So if you just can record yourself in terms of a video of 4 or 5 minutes, tell me about yourself. It's more or less kind of explaining yourself, explaining your caliber in those many minutes, and try to record a video and post it in a group, and we'll try to understand how ready you are in terms of taking up the interviews, because steadily, progressively we need to reach there someday, right? So if you start working on it proactively, that will be really going to help us in a long run. So that's what I'm trying to suggest. Try to record a video. You can do it with Zoom. You don't have to be using any purchase Zoom logins or something. You can do it with the normal Zoom as well. You can record on your computer, and you can basically try to listen to it. If you find any shortcomings, you can record it one more time, and so on and so forth. It's not that big deal. It just take 10-15 minutes to get this thing recorded, right? So this is a kind of overall progressive steps which we basically take to make sure we are in line with the overall interview ready sort of scenarios. So that's why. Yes. Okay, let's park it for the next time then. No worries. Okay, let's start to understand. I'll just revise the entropy and gain again. Where I've started. Right. So basically, what we try to do, we try to build the data. Let's start with the step overall. How data scientists approach a given solution. What do you try to understand? Try to collect the business requirement, understand the business requirement, or basically understand the vision, mission, where we are trying to create a solution for a particular reason, right? So try to understand reason. Try to collect the necessary data, whatever available. This can be with multiple sources. This can be with multiple, organizations, multiple individuals as well. We try to clean that data in terms of what we need, what we don't need. So if you ask, just take a big example, like you want to understand how many COVID positive were there in the age group of 50 to 60 in the Midwest region, right? And we want to understand a month-wise progressive, curve on that, 50 to 60 age group. I'm just trying to make business requirement sound more realistic, more practical, and we'll basically try to understand how we how we come across entropy or gain. Okay, here we collected the data. The basic data I'll collect from the local census body, trying to understand how many people are there residing in the Midwest region or whatever region you're trying to analyze. Then I'll go to the local, COVID body, who are basically helping out to supply medicine, to track down how many patients are there and all those things. And I'll try to collect data from them. Now what I'll do, I'll try to match these data for a typical age group of 50 to 60. Now rest of the data, I can let it go. I can remove, I can, basically, give it to others if they need it and something like that. So I try to collect the data. I try to clean it in terms of whatever I need. And then I try to align it. Aligning can be as simple as, changing the sequence of column, writing down some SQL queries or writing down some, logic behind the whole solutioning purpose, right? And then I'll prepare these things. So I'll prepare the data in terms of I'll have a name, age, COVID positive or not, and the dates when they, they analyze, they are checked for COVID, and so on and so forth. So I'll have these data, and then I basically try to create a curve or a basically graph where I'll understand how many were there COVID positive in, let's say, in January, February, then March, and so on and so forth. So this way, I'll try to build a solution. So in this whole step, what I'm trying to do, I'm trying to collect the data, I'll try to clean the data, I'll try to prepare the data, and I'll try to present the solution. Now present the solution here because the need was to present a solution. In some scenario, we might need to deduce some results, deduce some human-like statement interpretations based on the data, right? So this is what the data scientists overall do. Now, let's try to understand the entropy or gain, in this. Now, what you say, gain is basically, we are talking about the necessary data required to prepare a solution. So within cleaning, I'll try to remove entropy as much as possible. So I'll basically decide which are the data which is much more aligned to my requirement as of now, and let it go of the rest of the data. Now, the gain is basically what I'm gaining towards my position. You can simply, in the layman's term, try to understand that. So whatever I'm trying or I'm interested in building is my gain. And then rest of the thing is just entropy. So I need to let it go. Now, when I talk about a simplistic data, it sounds much simpler. But in a normal practical scenario, we normally tackle with petabytes of data. We normally tackle with terabytes of data. So what we do, we did some mathematical calculation around this. We try to understand how we can get it done from the system rather than me doing everything. So for each and every such interpretation or a human-like inference drawing out of data, we create a formula in terms of entropy and gain. And these are the formulas basically. We have the programs already ready for calculating entropy and gain on a particular set of data. I'll fill in those respective formulas, respective details, and try to find out gain or entropy. Now, I want to maximize my gain and reduce the entropy as much as possible. Now here what I'm trying to do, I'm trying to reduce the dirtiness and try to create more and more alignment with my requirement. And that's the whole concept is all about. We try to understand it mathematically. We try to understand with two examples, I believe. One is from that, if I can play outside right now today or something like that sort. We try to jot down a couple of scenarios there, and that was the table. Let me try to pull out, no, not in deviations. The second one was, am I allergic to peanuts? Should I eat a peanut butter cookie or not, right? So I started thinking, am I allergic? If I'm allergic, then I don't touch, I have to let it go. Means, I can't eat that peanut cookie. If I'm not, then, well, will it ruin my dinner? If there are any other challenges pertaining to if I eat cookie now, will it ruin my dinner? And so on and so forth. So that way I plan it out step by step, right? So, we try to understand entropy and gain in a step by step, where we try to apply this thought process to different variables at a time, and we try to progress it out towards a better results, towards a better understanding of a given situation. Now, this is what a step-by-step evolution we normally refer as a decision tree, right? We had a look at it. And then we have something called confusion matrix. And confusion matrix, we try to create or try to categorize the results of the feasibility of the data into 4 quadrants. What are those? Actual no, actual yes, predicted no, predicted no, predicted yes. So here we try to understand how basically we can get leverage from these 4 quadrants, disintegration of a data, and try to walk towards actual, reducing the entropy and gaining more gain in a step-by-step process. So here I'll know what data to be actually most important for me. What are the data which can help me to deduce the results which I am looking for, and then the rest which I can just let it go, and so on and so forth. So I am trying to progressively build my data scientist solutioning with entropy, gain, decision tree, and the confusion matrix type of tools and techniques which are devised over the years by data scientific community. Okay, any confusion so far?
No.
No, we are clear.
Okay, now here what we are trying to do, we are trying to categorize into 4 quadrant. It's a 2 positive. These are the cases where we predicted yes. They have the, this is talking about that 165 observation we took from a person if they have the disease or not. We can think about COVID as in disease. So we just checked with 165 individuals, do they have COVID or not? And 2 negative we predicted no, but they don't, and they don't have the disease. So 2 negatives are good, means whatever they are saying, that's the truth. Then false positive, we predicted yes, but they don't actually have the disease. They might feel like they have, but actually in reality they don't have the disease. Okay, and this is what we call type 1 error. And these things do happen. There are persons in real life who try to present themselves even if they don't have the caliber, or they don't have the necessary skill set to do it, but they say, yeah, I can do it, and so on and so forth. So we have quite a few false negatives within our day-to-day life as well. Then false positives. Now false negative we predicted no, but they actually do have the disease. So there are some persons who actually says no, I don't have disease, but actually they have the disease, and we got these inference after we check them medically. And so this way we try to clarify our thought process step by step, try to improve gain and reduce entropy in a procedural way, because these entities which I'm trying to investigate are not known to me, are not that well known to me. If it's known, then well and good. I can clearly start building entropy by observation also. But in most of the cases, I normally work on a data elements which are not familiar to me in a given data scientist solutions. So step by step, I build more and more entropy. I try to build more and more gain and reduce entropy progressively. Now let's try to understand decision tree. Decision tree is a common terminology used in a solution wherever we try to basically uh, build some decisions, build some overall procedural step-by-step progress for a given data scientist solution. A decision tree is a flowchart-like structure in which each internal node represents a test on an attribute. So what we are trying to do, we are trying to clarify each and every variable in a step-by-step process. Whether a coin flips, comes up heads or tails. Simple. This is the simplest possible example you can give to the interviewer also. Each branch represents outcome of a test, and each leaf node represents a class level decision taken after computing all attributes. So in a coin scenario, you just flip a coin. If it's a tail, go this way. If it's a head, go that way. We have done these things quite a few times in our life, right? We use flip a coin where we couldn't decide. So progressively taking a decision in a probable sense of a 50-50, we use coin as an instrument or coin as a base for decision support. Now, this is what we talk about, a decision support tool. So decision tree is that decision support tool uses a tree-like moral of decisions and their possible consequences, which path to choose, whatever I have to decide after flipping the coin, including the chance, event, outcomes, resources, cost, utility. There could be n number of variables depending upon your progressive path you're choosing here, or the solution at play here. It is one way to display an algorithm that only contains conditional control statement. So with the decision tree, what we are trying to do, we are trying to narrow down the outcomes to actual choice what we have in terms of progression. So wherever we think, let's say in terms of a coin flip is the most easiest way. Let's take a step further and try to understand, should I go out and play? Simple one, right? I'll have a look at out of my window and try to understand. It's a day. I want to go out and play. I can play anything. So, I can play with my dog. I can take a dog for a walk or not. So these kind of decisions. So let's say I'm sitting in my home and trying to look outside. Can I go without for a walk with that dog? And the decision basically is based on quite a few scenarios here. Is the time right? Am I disturbing any of my already planned schedule? Is the environment is good? Is it rainy? Is it have clear light? Or am I basically walking into danger? And so on and so forth. So these are the normal branch of a tree, what we need to consider before actually going to the end results. And we need to consider all this probability in a given scenario, because we are trying to implement this decision tree in a on a computer or in a digital format. Okay, let me play a video for you on decision tree analysis, where we try to understand how we normally analyze in a given scenario. Okay, what we do in a decision tree analysis in a step-by-step procedural way. I go and try to understand how I can basically help my decision, support with all those this one we had.
Hello friends, my name is
I don't want to repeat those things. We had another, but yeah, I've shown you this way. Do you want to show it again? It's really.
Hello friends, my name is Radamasu. Today we'll discuss
wait
about the topic decision tree analysis. And today's topic,
Yeah. Do you want to have a look at this video again, or you had a look at it?
No, I think we already
You
saw
had
this
a
in
look
the
at it.
last one.
No problem. Let me check out if I can find another good animated decision tree. Okay, let me play this thing. Okay, let's try to understand this one.
and welcome back again to mbabullshit.com. So the topic for this video is decision tree analysis. This is the basic video on this topic. All right, so remember, you can always go back to mbabullshit.com. After this, you'll be ready for my next video on decision tree exam training to help you pass or get high grades. All right, so let's start with a story. Let's say you can choose between two business projects, either a candy shop or a lemonade stand. All right? And let's say that the candy shop can earn up to $100 and the lemonade stand can earn up to $90. Which one should you do? Of course, the answer is quite easy and obvious. You should choose the candy shop in this simple situation. The what if, okay, but what if, let's take the story a step further. What if the candy shop had a 50% chance of success and also had a 50% chance of failure? And if your candy shop is a success, you would earn $100. If it was a failure, you would lose $30. See, that's a negative sign there, a negative 30. On the other hand, if you have a lemonade stand, you also have a 50% chance of success and a 50% chance of failure. If it's a success, you would probably earn $90. If it's a failure, you would probably lose $10. Which one do you choose now? Okay, so now it's not so simple. Actually, it is very simple. You would use a simple formula like this. Okay, and it would look like this. 50% times $100 plus 50% multiplied by negative 30. And we would get a figure here, which we call an expected value. Now, I'm going to explain that a little bit more in a while, so just be patient. Where do we get this 50% over here? It's the same as the 50% over here. Where did we get the $100 over here? It's the same as the $100 over here. Plus 50% over here corresponds to the 50% over here, chance of failure. Multiplied by negative 30 or a loss of 30, where did we get that? It corresponds to the negative $30 over here. And now we come up with this $35. And then we do the same thing for the lemonade stand. 50%, okay, 50% chance of success, $90 that you would earn if it's a success, plus 50% chance of failure, multiplied by the loss of $10, which you would get if, or which you would have if your lemonade stand becomes a failure. Okay, and we end up with this formula over here and this figure over here. 50% times 90 plus 50% multiplied by negative 10 equals $40. So now which one would you choose? Obviously, would you choose the $35 or would you choose the $40? Obviously, you would choose the $40. And this $40 is what we call the expected value of the lemonade project. And the expected value of the candy project is $35. And since we're choosing a business, we choose the bigger one, the one with a bigger expected value. Now, I promised you I'd speak more on expected value. What do we mean by this? All right. Well, does this mean that if you do the lemonade project, you will earn $40? Okay, $40 over here. Does this mean you will earn $40? No. Okay. It means that if you did identical lemonade project very many times in exactly the same situation as you have here, okay, if you did it very many times in exactly the same situation, then your average earnings.
The strength of decision trees are basically we are trying to build certain decision on the basis of certain facts and figure and alternatives available to us, right? So decision trees are able to generate understandable rules, more of business rules, more of human rules, what we're talking about. So the alternatives available are chosen from these set of variables and the combination thereof. The decision tree performs classification without requiring much computation. You know, we are just inputting these variables. The formula is same, right? For each and every permutation combination, we are using the same formula. We just need to decide what type of gain and entropy we are reaching at a given selection of variables. So these are all permutation combination of output, and then we'll plot it on a decision tree, a hierarchical tree with one and many alternatives and so on and so forth. The decision tree are able to handle both continuous and categorical variables. Continuous in the sense evolving variables. Categorical in the sense we have a finite result in hand and then we can apply those variables in a given decision tree. Decision tree provides a clear indication of which fields are the most important for prediction in classification. So if it's raining, you might not go out, right? As we seen in the last example. If it's windy, then only you don't like to go outside. But again, there is a bit of possibility. If there's a windy, I might go for play tennis. But in rain, I normally don't play tennis. So like this, some variable are more decisive. Some are on a probabilitical value. Some are quite gray area. And these formulas segregate them in a step-by-step way. Okay. Let's try to understand how we have done it again in terms of yes, no. And this is what we call, oh, come on, why this is showing me here? Oh, this is really irritating. I don't know. Give me a minute. I don't know what happened, but let it no one. So again, the same example where we have tried to understand how to decide, right? So here we have just built a hierarchical tree of how we are implementing the decision from a set of values which we will consider for a given example. Okay, so here we have a set of value, we have set of root node, we have set of predictions, targets, and we build decision tree on based on that to reach to an actual decision. Now, probability wise, this can be 50-50, but at the end of the day, you have certain variable pertaining, inner true values, right? And then you decide based on them, which are the true value currently, and then execute the decision based on this decision tree. And that's how we implement our solution for a given, prediction for a given situational facts at that time. And that's how we implement decision tree in a given program. Then decision tree classification. Again, how do we normally go on classifying? Why we choose these nodes, variables, leaf nodes, branch, and all those things. Let's try to understand from the, understand again in detail so that we can plan a decision tree in our given program. Decision tree builds classification for regressions model in the form of tree structure. We've understood that. Any confusion there? We've seen the hierarchical progression of decision, right? And then in a step-by-step way, we are building some decision tree in a successive manner, right? In a step-by-step way, plotting the alternative across the branches, right? So there we are building our branches based on all these regression models. It breaks down a data set into smaller and smaller subsets, while at the same time, associated decision tree is incrementally developed. So the T get progressed as per the division of events or division of progressions, and we plan the overall regressive. Was the word they have used? Progressive disintegration. The final result is a tree with the decision nodes and leaf nodes. A decision node, that is what we call outlook, also has 2 or more branches like sunny, overcast, rainy, windy, and all those things as per depending upon your data set of consideration here. The leaf node, a play or actually a branch, represents a classification of a decision. So we have those many alternatives, the way we decide the alternatives available to the decision in a concerned data sets. The topmost decision node in a tree, which corresponds to the best predictor, called root node. So root node is the best predictor in a decision tree. These questions have been asked quite a few times in the interview. So if somebody asks what's a root node is the corresponds to the best predictor in the decision tree or topmost node in the decision tree. Decision tree can handle both categorical as well as numeric data. As we've seen, we can consider yes and no, we can consider the numerical data, and so on and so forth. Does that make sense to you? How we build this decision tree?
Yeah.
Please leave the formulas and the classification to the program, but you should understand the structure, how we implement decision tree. It shouldn't look like a magic to you, the way the program decides for you. But overall, we should understand how decision tree progress. And we have to just apply. We don't have to keep programming a decision tree or keep building a decision tree. You just put in the number of variables, number of data elements, the root node and the alternatives, and the program will give you the output in the numbers in terms of entropy and gains. And that's why we are learning these terminologies. And these terminologies give you a decisive factor whenever you are at a juncture to decide based on a decision tree. And the algorithm which we normally or most probably use is ID3 algorithm. There are quite a few algorithms. We'll see those algorithms in a few slides, but still, the most used algorithm is ID3. Okay, and we'll have a look at why it's named as an ID3 only. So, if as we same thing, play tennis or decide to go out, whatever you're deciding, and this is how we can calibrate the decision tree based on the probabilitical outcome. So there are few numericals and there are few the decision based on the conditional as in yes or no, and this is how we basically deduced our decision tree in a step-by-step way. I'll show you a complete I'll share a link from a geeks4geeks.org where how decision tree is implemented, and have a look at it. And the correct way to understand this is try to jot down a problem of your daily life, can be how to reach office effectively, and build a decision tree on based on that, or what to cook in the night, or what's the best sitcom I should watch. Should I watch Friends? I don't know what all sitcoms are coming on your television right now. Should I watch House of Thrones? Should I watch House of Cards? Should I watch West Wing? Whatnot. So you can build a decision tree based on your current practical challenge, which will give you a clear idea how we build this decision tree. I'll basically share those way we just discussed in terms of how we compute it with a given formula, and you can use this formula from a program as well. But please do try to at least build a data set of your decision tree, and then we might build a decision tree in our next session. Okay, but try to please think it through. Give it a try. That's what I'll say, so that you'll understand the terminology in a much better sense. This is the crux of data scientist solutions. This is how we decide based on a solution, how many outcomes, alternatives, and so on and so forth in an evaluatory manner. So this is the kind of basics for data scientist solution building. Okay, does that make sense, sir, Mana?
Yes.
Chalo. Let's try to revise again, and then I'll close. I know it's a lot of theory and lots of going through, so I don't want to stretch you longer. But let's revise in a scientific manner. What is entropy and what is gain overall? So entropy is a scientific concept as well as a measurable physical property that is most commonly associated with a state of disorder and randomness. This is the actual IEEE definition of entropy. I have not shared this definition earlier because it's confusing, right? Unless and until you know the state of disorder or randomness. So whenever we try to understand the state of disorder or the actual noise, as you say in the data, right? So once you understand that randomness or state of disorder, then you can relate the entropy to the noise a far more better way. So I'll repeat again. Entropy is a scientific concept as well as a measurable physical property. Something like temperature. It's a scientific concept, right? So how we label the temperature, we label on a Celsius or Fahrenheit mode. Both are scientifically proven. Neither one is wrong. There are two ways, right, to measure temperature. But if you start presenting both the way at similar time, it becomes an entropy because it's a state of disorder. Either you tell me 30 degree or you tell me how much 30 degree correspond to in Fahrenheit? Around 86, I believe. Don't quote me, but something around that. So if you start measuring right now, the temperature is 32 and 86. The other person will get confused. Is it 36.82 or is it 82.36 or is it you don't know and you're just trying to throw some number at me. So something like that. So let's not build a state of disorder. Let's try to reduce the state of disorder and try to use some precise numbers or precise decisive methodology. So entropy, again I'll repeat, a scientific concept as well as a measurable physical property that is most commonly associated with a state of disorder and randomness. One dictionary definition of entropy is that a measure of thermal energy per unit temperature that is not available for a useful work. The most important part here is not available for a useful work. So when let's say if you're in India or any South Asian country, we normally go by Celsius unit for temperature. So if give them temperature in Fahrenheit, so that's what the measure of thermal energy per unit temperature that is not available for a useful work, which is not useful or understood by the given concept. So that's a noise, and that's how we normally refer entropy to in a cyclic process. For instance, a substance at a uniform temperature is at a maximum entropy and cannot drive a heat engine. Like a coal, right? At a uniform temperature, it can't drive a heat engine. A substance, non-uniform temperature, it has a lower entropy than if the heat distribution is allowed to even out, to exert. Some of the thermal energy can drive a heat engine. This is a concept where you normally Newton explained the heat dissipation for a given metal or non-metals, and that's where this entropy is actually we started understanding the concept of entropy, and then it came into the mathematical formulas and we start understanding the entropy overall. So the formula is extracted from the heat dissipation thought process of Newton and subsequent scientific research. That's why entropy is normally mentioned in a thermal unit or temperature units. But in a mathematical sense, it's just a number, it's just a disturbance or noise. A special case of entropy increase, the entropy of mixing occurs when two or more different substances are mixed. If the substances are at the same temperature and pressure, there's no heat exchange, there's no net exchange of heat or work because they're at a horizontal level. The entropy change is entirely due to the mixing of different substances at a statistical mechanical level. This result due to change in the available volume per particle with mixing. This also explains why sugar dissolves into water, milk, tea, and at what rate it will get dissolved much faster. So if the water, milk is warm, sugar get dissolved faster. If it's hot, it get dissolved at a much faster rate because the molecular links broke down at a faster rate whenever you try to induce heat into the whole process. This is again the scientific aspects of entropy. We need to understand in terms of when you want to give an example, you can give all these examples. I have shown this example to you to make you understand how entropy is represented in a real world, in a real scientific world. Okay, have I confused you more, or could you understand how we can explain entropy on a to a scientist? Please guide me about your thought process.
I think I understand it mostly, but if you could just share the slides afterwards so we can revise, then it would be good.
Definitely. I'll do that, no problem. But the understanding of concept is important so that you can read and explain at a next step.
Understood the bit.
Thank you, ma'am. Now, basically, let's try to understand how do we, implement this entropy formulas in our programming. We will import counter from collection library, which is build modules in Python 2 and 3. Entropy was actually implemented as a static programs or the programs which are ready-made, and we just use those library from Python 3 onwards. We are currently at Python 3.9. So if you choose anything like in Python 2 or older programs, then you might have some different challenges to face in terms of calculating entropy by the program. You might need to cut, copy, paste the formulas from some other programs. But I believe if you are using the latest, Python, you will not have any challenge. I want to mention this because just to make sure we are on the same page in terms of whenever we're trying to calculate entropy or gain, we are clear in terms of the environments we are using. This model will help us to count duplicate elements in a list as well. So they try to use a method called successive elimination. It's a probabilitical statistical method which computer normally use to reduce the calculation at a programming level. We define a list of numbers and calculate the length of the list. We call the counter a dictionary subclass. We've done programming with counter, which helps to count hash table objects, the records basically, if you want to go with a layman's term, and then we convert to a dictionary object. If it's not a dictionary object, we convert the data set as a dictionary object, and we've seen how we do that previously in a program. We then initialize a list with a for loop to compare all dictionary numbers or dictionary values of the elements to the max dictionary values. So we normally arrange them or align them as per the sequence needed for calculation. Count the most occurring element, and it returns all the elements equal to max count. If the elements returns are equal to the number or total elements in a list of total elements of list, then we print no mode. Else we print out the modes which are returned. So these are distinctive counts on a given data set. Okay, just to understand this better, how we use descriptive statistics here, let's try to show me a video and then we'll end for the day. The Excel collection for descriptive statistics. Let me open that video for you. Where am I?
In this video tutorial, I'm going to
Wait a minute. Let me share this for you. I'm trying to